I want to give you a bit of a review here about what pH is and the pH scale and how we can link that to strong and weak acids and strong and weak bases. So the pH scale goes from about 1 to 14, and at this end, at the low end of pH, we've got strong acids. At the high end of pH, we've got strong bases. In the middle, we've got neutral. So around here, you're going to see strong acid, like HCl. Around 5 and 4, you're going to see weak acids. Around 7, you'll see neutral. Around 9 to 10, you'll see weak bases. And then at 14, you'll see strong bases. So this is a scale that most of you should be familiar with. Let's take a look at how we know when acids are strong and weak, or when bases are strong and weak. The strong acids, or the ones we know that are strong, are these ones here: sulfuric, hydrochloric, hydrobromic, hydroiodic, nitric, and perchloric. The reason we call these strong is that when we put them into water, like HCl, we put it into water. After it's put into water, there's 0% of HCl left, and it's all become H plus and Cl minus 100%. That's what defines a strong acid. Now, a weak acid, when you put it into water, what happens is that at the end you'll still have 97% of the acid you started with, and only 3% has actually dissociated into H plus and an anion. So these are called weak acids. Likewise with bases, something like sodium hydroxide, it will dissolve completely in water and become Na plus and OH minus 100%. That's what makes it a strong base. Something like NH4OH, ammonium hydroxide, 98% of it will remain in the undissociated form, and only 2% will actually become NH4 plus and OH minus. That's what makes it a weak base. The strong bases are metal hydroxides. You can pretty much easily tell them. They've got OHs here and they've got metals next to them. All of those are going to be considered to be strong bases. So what I would say is all these here are strong acids, and you should know those. And anything else you can consider to be a weak acid. These are the strong bases, the metal hydroxides, and then you can look upon anything else as being a weak base. So that's the best way to know whether acids are strong or weak, or whether bases are strong or weak.